Okay, I'd like to go over any questions you have about the section 1.6 homework. So does anyone have any questions about section 1.6? Michael. 105. So again, these homework problems will be at the bottom of the section 1.6 tab in the notes. 105. So we're looking at right? Is this what we have here? Right? Okay. So this is one where we're going to have to use that test point method to figure out what the solution to this inequality is. So what we're going to have to do is look at the denominator, right? Because we can't have the denominator be 0, right? So when we look at just like x plus 2 equals 0, right? If we want that equation to be true, x has to be negative 2. So negative 2 is going to be one of the points that we're going to have on our number line. So we know we're going to have negative 2. What other values are we going to have? Because this problem is very similar to this last one I did, right? Where you're trying to figure out, I actually forgot the first step, right? We have to get 0 to be on one side of this equation. So let's back up. We have that 3 sitting there, so let's not do anything just yet. You could just forget I ever said that. So now we're less than or equal to 3. What we're going to have to do is bring over that 3 to this side, because we got to get that 0 over there. Sorry if that confused everyone. We have to get that side to be 0. Okay, now we have to combine these fractions. All right? So to do that, if you remember, I'll write it over here again. If you had a over b plus c over d and you want to combine them, you could just do a times d plus b times c over b times d, if that looked familiar, right? We did that a couple times, combining rational expressions. So let's just do that again. And in this case, d is just 1, right? The thing underneath the 3. So we're just going to have x plus 1 minus 3, and this is plus or minus over here. So the minus over here is fine. Minus 3 times x plus 2. And then the denominator is just x plus 2. And now we'll simplify the numerator. And let's see what we'll get. X plus 1 minus 3x minus 6. And then x plus 2 was actually remained on the bottom. And then simplifying a little more up here, we're going to have negative 2x and then minus 5 all over x plus 2. All right, now we're ready to put some stuff on the number line. So I'll put the number line up here. We can't have the fraction be undefined, so that means x plus 2 cannot be equal to 0. So x is can't be equal to negative 2. So negative 2 is going to show up on our number line. And then also for the numerator, what are we going to do with that? Right, if we go back to our example, right, we eventually got to be x plus 6. So that's the thing that has to be less than or equal to 0. So we have negative 2x minus 5 less than or equal to 0. So we just solved this. So it's negative 2x is less than or equal to 5. And then now when we do this division, right, it's x is greater than or equal to, it's going to be negative 5 halves. So negative 5 halves has to be on our number line. So let's put these on here. So negative 5 halves is negative 2.5, but I'm going to spread them apart. Let's see. So negative 5 halves will be over here, and this will be negative 2, and then I'll just throw the 0 over there for now, just so we know that we're in the negative part of the number line. Okay, so we have to look at some intervals here. Now we can ignore the 0 for the intervals. We're only going to have 3 of them, right? We're going to have negative infinity up to negative 5 halves. We'll have negative 5 halves to negative 2, and then negative 2 to positive infinity. Okay. Now, right, I mean, we're essentially looking at this area, and then everything greater than -2. So far, so good. Okay. Test values. Again, you're trying to make these simple so that your calculations are easy to do. So for anything that's from -5/2 to -infinity, why not choose -3? It's a nice whole number. This one's a little tricky because it's -2 to -5/2, so like maybe we'll choose -2 1/4. Maybe that'll be useful. It's sort of just like the simplest fraction between those two numbers. And then for greater than -2, if you can get 0 as a test value, that's always going to be to your advantage. Okay. So far, so good. Okay. So in our original equation here, right, we just have to do what? If we go back to our example here, right, all we're worried about is the sign on the fraction that we ended up having, right? So in this case up here, we had x plus 6 over x plus 1. So that's what we're interested in doing down here with this fraction. Okay, so we're going to be doing, so the signs, all right? We don't care about the numbers. We simply just care about plus or minus for each individual part of the fraction. So for the numerator, if I plugged in a -3, right, so it would be -2 times -3, which is +6 minus 5. So that's a positive in the numerator. And then in the denominator, it will be -3 plus 2, which is negative. So the result for when we're less than -5/2 is a negative number. And then we just repeat for these other values. So now we'll have -2 1/4. So, all right, -2 times -2 1/4 is going to be a positive. It looks like 4.5. So 4.5 minus 5 is going to give me a negative numerator. And then -2.5, 2 1/4 plus 2 is still a negative number. And we end up getting a positive result for that one. And then the 0 case here is simple, right? If you plugged in a 0 for the -2x, it just goes away. And you have -5 over a positive, so it's negative over a positive, and we get negative. So now what I suggested we do, just to visualize this on the number line, is put these signs here. So for less than -5/2, it's negative. And then for between these two values, it's positive. And then it's negative again here. Now, to give the final solution, you have to look at this part of it, right? The solution to this inequality is any number that is less than or equal to 0. So if the result is negative, like you see from less than -5/2 and then greater than 2, that's a part of the solution set. And because it's less than or equal to, we're going to have some square brackets involved. So here's the final solution here. So here's the final solution, and we'll give it, an interval notation. So we're going to go from -infinity to -5/2, but it's going to be a bracket because we're talking about less than or equal to. And we're going to union, which just means we're going to add these two intervals together with a bracket on -2 all the way to +infinity. So there's our final solution here. Now I understand that these problems take a little bit more time than, let's just say, solving, a linear equation. So I took that into account on the exam if you were to have to do this, right? Because there's a lot of steps. First thing you got to do is put the rational expression in the form where you have a 0 on one side. Then you have to go ahead and combine two fractions. Then figure out the numbers that need to go on your number line. Figure out your test intervals. Figure out your test values. Then your signs. Then your results. And then based upon what your inequality symbol is with your 0, that depends on your solution. All right, so there's a lot of steps. So my advice would be go through all these steps if you had to do something like this on the exam. And I'm not necessarily saying it's going to be a complicated one, but just give me as much work as possible. Because if you make one mistake somewhere and it's very small, I could give you as much partial credit as I can. Does that help? Going through seeing that process again? Any other questions in 1.6? We're okay? Okay. So here's what I like to do. I would like to, we're going to do an exam review today where I kind of walk through every section. But I wanted to go ahead first and just finish up chapter 1. There's only one more section that we have left. This section will not be on the exam. And it's just a couple different types of problems involving absolute value. Okay? And actually, we'll be solving some inequalities and solving some equations by doing this, so that'll also help with the review. But I will spend some time at the end kind of giving you problem types to study. Okay? So that's my plan for today. All right, so let's jump right to 1.7. Let's change the color here. Let's go there. No, I don't want red. Go blue. All right, so this is section 1.7. And this is equations and inequalities with absolute value. Okay. Everyone in this room has used or seen absolute value before, right? If I had something like the absolute value of 4, you would know the answer is 4, right? Same thing if I did the absolute value of -4, the answer is also 4. So I like to think about absolute value in my head as basically just it's the positive integer or decimal or whatever's stuck inside that absolute value symbols. You just get the positive result. So it's like you're stripping away that negative sign. All right. So obviously this could be, I could put plus or minus a inside of a absolute value symbol, and I'm only getting out a. Okay. So you could write out equations though, and that's kind of what we're going to be doing in this section. So like if you had the absolute value of, let's just say some polynomial u, okay, and we had that set equal to another variable a, all right, we can't just solve this equation, all right. What you have to do is you have to break it up into 2 equations, right, because u, right, can be equal to a, but then also negative u can be equal to a as well, right? You could split that up because there's 2 possibilities for u to be in this equation, all right? So what we're going to do is we're going to start solving some problems, and I'm just going to give you the different types of forms of the different types of equations you can see, and there's not many. And they're very simple. There's 3 forms of equations, but it's about 3 forms. Okay, so here's the first form. Okay, if you see something like x minus 2, so that's a little binomial in absolute value symbol, equal to 0. Okay. Now this is a special case where 0 doesn't have, it's not positive and it's not negative, right? So there really only will be one solution to this. So what you would do is you can think about just letting, because we're going to use u for all of these things, let u be equal to x minus 2. And if the absolute value of u is equal to 0, and then really all that means is u has to be equal to 0, right? Because there's no plus or minus involved with that. So if you ever see an absolute value polynomial and then there's 0 on the other side of the equation, I mean, you literally just go x minus 2 equals 0, so then x must be 2. I mean, no, what did I just do here? Yeah, I'm sorry, x has to be 2. All right? There's no other value that can actually give you that solution. Okay? So that's form 1. They're the simplest ones. You see a 0 over there, you're good to go. Now what happens if you see a form like this? All right, so we're not going to have a 0 involved. So what you're going to want to do is isolate the absolute value. Isolate it. So it means just get it on one side of the equation. So I'll have 6x minus 3 equals, and I bring that 8 over, I'll get a 9. Okay. All right, so what we're going to do is we're going to let u equal the thing inside the absolute value. And here's our rule. If u is equal to 9, that means u could be equal to 9, or u could be equal to negative 9, right? Because the absolute value strips off the negative sign. All right, it's just what we saw up here with the 4s, right? 4 could be, absolute value of 4 is 4, but also negative 4 absolute value is also 4. So that's just basically showing you that here. So what you could do at that point then is plug in what u is. So you have 6x minus 3 equals 9, and then 6x minus 3 equals negative 9. So 2 equations to solve, and they're very simple. So 6x equals 12, so we have an x equal to 2. And then a 6x equal to, what is that? I'm going to add 9, or this is a 3, I'm sorry. That's a 3. So it's negative 9 plus 3, so that's negative 6. So then we get an x is equal to negative 1. So if you were to plug in either 2 or negative 1, you would get this equation solved. So that means the solution set is basically just negative 1 and 2. Those two values satisfy that equation. Yes?
So anytime there's not a 0 on the right-hand side of the equal sign,
yep,
you're always going to have 2
yes.
problems to solve.
Yes, this is, I would say this first form, I'll start labeling them. The first form is really a special case of this second form that we went over. Okay, the 0 one's easy because it's just whatever's in the absolute value has to be equal to 0. But that's because the 0 has a property of being neither negative nor positive. But in this case, when you have that absolute value equal to a number, you're always going to spread it out into 2 equations. Okay, that makes sense. So that's one form. Now they're very simple, and these are all actually pretty simple. There's just a couple other different forms. So here's another form. And I'm not going to give you many more examples because the homework assignment, and I'm not going to make this homework assignment due until next Thursday. So you don't even have to worry about it until after you take the exam on Tuesday. And then we'll go over some of these questions on next Thursday. But so it's a very simple homework assignment, just going through these different forms. So here's another form. I'll call this the third form. Okay. What if you had something that looked like the absolute value of some polynomial u equals the absolute value of another polynomial, and I'll call it v. Okay. So this is how we split this out. We would say, again, we're going to get 2 equations. One equation is going to be u is going to be equal to v, but then also u is going to be equal to negative v. Right? They're the 2 equations that we're going to end up having to solve. All right? And I'll show you how we apply this in example. So you're going to see something like the absolute value of x plus 2 equals the absolute value of x minus 3. So these will be easy to pick out because both things on either side of the equation are going to have absolute value symbols. Okay? Now what you could do is it depends on what you want to do. You could call this one u. So you could say u is the x plus 2 and then v is x minus 3. So how would that play out with the equations? Well, you'd have x plus 2, right? That's u. And then v is just, x minus 3. So there's one equation we have to solve. There's one. And then the second one is basically from here, right? The u equals negative v. So whatever u is, x plus 2 equals negative. Now here's the important part. Whatever v is has to be put in parentheses because that negative sign has to be distributed through every term in the polynomial. So this would be x minus 3. Now you just solve these simple equations. So what do you get over here? With x plus 2 equals x minus 3. I must have bumped the program. See how the x's cancel out and you get 2? Oh, stop it. You get 2 equals negative 3. Is that true? So that's false. Okay. So you can ignore that specific case. Now, as soon as that symbol gets out of the way, we'll continue with the next one. Okay. So now to solve this equation, again, distribute this negative sign is important. Negative x plus 3. Well, now you'll see if I bring that negative x over, I get 2x. And then if I bring this 2 over, it's 3 minus 2, and I get 1. So then x is equal to 1/2. Okay, so x equals 1/2. That's the only solution to this equation involving absolute value. Yes?
Will they ever be true in both of them? Not one being false? Will they ever be both solvable?
It's possible. Yeah. So I would just be on the lookout, And again, you're just solving these equations, so if you come up with 2 equals negative 3, that's false, then, whatever. Now, if that came out to be true, what does that mean? What kind of equation is it? This is a section 1.1. It's a good review. What happens when you solve an equation and the two numbers on either side come out to be the same? What's that called? There's two types. There was inconsistent and identity. Which one is it? If numbers on both sides come out to be the same, that's an identity. So what does that mean? Well, an identity means that you could plug in any x value and the sucker's true. Okay. Now this one where 2 equals negative 3, that's inconsistent, right? But we don't care because since there's absolute values, there's a possibility that there is a solution with the other equation, and sure enough, we're good to go. All right, we have 1/2. And think about it, when you plug it in the equation, you have 1/2 plus 2, so that's 2.5. And then 1/2 minus 3 is negative 2.5, but taking the absolute value, you get 2.5. So our only solution is x equals 1/2. Okay? So the biggest thing is going to be, and there's one more here, the biggest thing is just figuring out which form you're doing. Okay? Is it the form where you have an absolute value equal to 0? Is it a form where the absolute value is equal to a number? And is it a form where you have two absolute values? Okay, so let's try one more as an example. And this really isn't even a different form. So we have, let me just give it to you. We have an absolute value, 3x minus 4, equal to a binomial. But it's not in an absolute value. Okay? So we have to make u something, right? So let's do this. We're going to make u the thing inside of here. And doesn't this look a heck of a lot like form 2? Right? We have some absolute value piece equal to something on the other side that's not in the absolute value. Same thing here. It may look like a different form, but it's really not. All right, so what did we do there? Well, we said 3x minus 4 has to be equal to 2 times x minus 1, but then also 3x minus 4 is equal to negative 2 times x minus 1. All right, we're just tacking on the negative sign, right, as the two possibilities. And then you go ahead and solve, and let's see what happens. So 3x minus 4 is 2x minus 2. And we get, let's see, I'm going to move the 2x over here. We get an x, and then it's negative 2 plus 4, which is 2. All right, so x equals 2 is a solution. Excellent. Moving on over here. Let's see, we're going to add the 2 on this side, we're going to get 5x, and then add the 4 over here, we're going to get 6. So x is 6/5. Also a solution. Okay. So don't be worried if you see, not a number on the other side of an absolute value. They're the same form. All right, so really you're just worried about 3 absolute value forms. So any questions about those? I hope they're pretty simple because it's just working with very basic linear equations. Are we okay with those? They're not too bad. And again, these aren't on the exam. All right, one last type involving absolute value would be absolute value is involved in inequalities. Okay, so let's just go ahead and show you how to do these. All right, let's say we had 4x minus 1 in a inequality in the absolute value, and that we had less than or equal to 9. Okay, so what we want to do is we want to find the solution set to this equation. Okay. So this is basically all we have to do. And again, this looks like the form, like second form. Second form is going to come up a lot. So we have 4x minus 1 is less than or equal to 9, right? And then we have 4x minus 1 less than or equal to negative 9. Here we have 2 of them. So far, so good. That's all we got to do. It's the same thing as before. Now we'll go ahead and solve these equalities. Oh, and by the way, when you do this, this is an and. If you remember from section 1.6, this is an and. Okay, so let's solve this. We have 4x is less than or equal to, let's see, I'm going to add the 1, we get 10. So x is less than or equal to 10/4, which is 5/2. Okay. And what do we have over here? We have 4x less than or equal to, I bring a positive 1 over there, we have a negative 8. And then x is less than or equal to negative 2. Okay. Good so far? All right, so it's an and. So we have to put these on a number line. So we have negatives and positives. So I'll put the negative 2 over here, the 5/2 over here. And we have to be less than or equal to. So we're going to do this. Go this way. And then x less than or equal to negative 2. So this one's interesting. So if you remember, we're worried about the intersection. So the intersection is here to the left, right? That's it. Again, you're trying to find where they coincide, where they overlap. So with that being said, my final solution, and wouldn't even have to graph it on the line, the final solution is going to be negative infinity to negative 1/2, and I have to have the bracket because I'm working with less than or equal to's. Okay. So when you're working with, I'll give you these rules here. If you're working with some absolute value where you're less than something, or the absolute value is less than or equal to A, these are both ands. All right, these are ands. The next example I'm going to give you, and I might as well write out the rules now, is if you're working with greater thans, you're working with the or. So let me give you an example of that. Okay, 2x plus 3 greater than equal to 6, so we have a greater than. All right, we're going to split this up. So it's 2x plus 3. We're going to do, do I have that wrong? Greater than equal to 6. And then 2x plus 3, and again, this is an or, greater than equal to negative 6. All right, solve these inequalities. 2x greater than equal to 3, so x is greater than equal to 3 halves. And then 2x greater than equal to negative 9, so x is greater than equal to negative 9. Okay? So I don't know if you could pick this out, right? If we're doing x is greater than equal to negative 9, and then x is greater than equal to 3 halves, the only thing that coincides is when x is greater than equal to 3 halves, right? When you think about the number line, right? Here's negative 9, here's 3 halves, right? The one solution is going to be starting here and going this way, but the other solution is already starting over here. So the only overlap is when we're going greater than or equal to 3 halves. So my final answer here is 3 halves with the bracket positive infinity. Okay? So I think the stuff in 1.7 is pretty simple. So again, I'm not expecting you to really even work on this homework because I'd rather you be studying for your exam on Tuesday. But I'm going to put it here so that you can complete it by next Thursday. So this is the section 1.7 homework. And we're looking on, it looks like page 164. And I have 9 to 23, 37 to 41, and then 55 and 57. Okay, and these are odd. So that's not really even a big assignment. All right, so I'll even write on here due, and it's not going to be in a Dropbox. This will be due Thursday, October 15th. We'll go over. Okay. All right, perfect. I wanted to get that 1.7 out of the way. One, because it just ends chapter 1. And, pretty much I like, ending it like that before our second exam. Okay, so now let's go back and talk about the exam, right? So here's our exam 1 review, or exam 2 review. Okay, so let's go by section and figure out the problem. So we'll go section 1.1. So when we go back there, it's just pretty straightforward. So, I was showing you how to figure out your exam grades there. Solving linear equations, right? And basically finding the domain, right? Finding the domain. So that's the first thing. I gave you a bunch of examples. The big thing with finding the domain is the only things you really have to worry about right now is, because remember, domain is the what real numbers result from the equation. Okay, so if like an equation results in solutions that are imaginary, we don't really count that in the domain. So the only two things you have to worry about are if you have a fraction, is it possible that the denominator could be 0? So like in this one, 3 minus x, clearly if x was 3, you would be undefined. So that's why we have all reals except x equals 3. And then in this example, we just had two different values that we had to deal with in the denominator. And then the other type was if you have a square root. The thing underneath the square root symbol, so the radicand, has to be greater than or equal to 0. So in this one, we solved that x had to be greater than or equal to 5 in order for the solution to be real. So my domain was all reals where x is greater than or equal to 5. Okay? So over here in exam review, one type of problem is determining domain. Okay? The rest is solving equations, checking to see if you're inconsistent or identity. So what I'll do in the review is just put solve equations, determining inconsistent or identity. Because that all kinds of fits in together. So you're just solving equations to determine inconsistency or identity. And then it looks like all we did was, you don't have to worry so much about this last section about solving equations with multiple variables, because you kind of do that in section 1.2, so we'll leave it for that. But the last thing is solving rational expressions. And we've been doing that a lot. So like in this example here, all I did was multiply all the denominators. That's just how we were doing it in section 1.5, which came out to be 36. And then I multiplied every term by 36, and that got rid of all the fractions. And then I just, solved the problem. So that's it for section 1.1. Section 1.2. Let's check it out. Now this was a pretty simple section in that I only gave you very specific ones to do, right? I gave you like this air conditioning repair bill, the reduced price sneaker, you saw that on the quiz. The exam scores, that was on the quiz too, I think, the exam scores. There was this simple geometry problem about the perimeter, and there was an investment problem. Okay, so what I'll do here in section the exam review, I'm just going to list one thing. I'm just going to say word problems. And I think I just want to make sure I get this right. 1, 2, 3, 4, 5. 5 types. So there's only 5 types I want you to worry about when you're studying for this exam. So just 5 types of word problems. That's it. That's all that's in section 1.2. All right, section 1.3. All right, so we're solving quadratic equations, and I gave you 4 methods: factoring, square root method, completing the square, let's see, quadratic formula, and that's it. Well, that's pretty nice too, right? Very focused section. 2, solving quadratic equations. And I'll give you the 4 varieties. You had factoring, square root method, completing the square, and then the quad formula. So I would make sure that you could do all 4 of those methods. But that's all we did in that section, was figure out how to do solving quadratic equations using those methods. Section 1.4. This section, all about complex numbers, right? So, you know, you have to understand what the square root of -1 means, right? That doesn't mean 1 over the square root of 1. It just means we're putting in this complex imaginary unit I. And then if you had I squared, that really comes out to be a -1, all right? If you have that in your head, we basically talked about standard form, right? Standard form of a complex number has a real part, which we usually put first, and then plus or minus the imaginary part, which has that imaginary unit I. All right, so I'm assuming standard form, that's something that hopefully not a lot of you have to study, but if you do, that's fine. What we did after that was basically, and I'll put it here, I'll just call it math operations with complex numbers. Right? How do you add them? How do you multiply? Right? How do you do? That was pretty much it, right? Distribution of them, multiplication, and addition were the main problems that we did. Right after that, I don't even have to go back to. We wanted to rationalize denominators, right? If you have an I in the denominator of a fraction, that's really like a square root. So if you think back to section, I think it was P5 maybe, when we were rationalizing the denominator and you had to use the complex conjugate, that's exactly what these problems are. You just have some i's involved. So hopefully that's not even too bad of a thing to do. And then the last thing I believe in this section we're solving quadratic equations with complex solutions. Okay. Now, before I go over section 1.5 and section 1.6, I bet you if you go back to your quiz 3 and 4, right, on section 1.1 and 1.2, that was quiz 3, and then section 1.3 and 1.4 was quiz 4, you will see all of this on there, right? So that means you can go back to those quizzes and practice those problems again as another subset of problems to practice. And again, go back to exam 1 and then those quizzes and see if there's a lot of similar problems. Okay, I'm trying to give you some test-taking strategies here. Go back to that exam 1, go back to quiz 1 and 2 and see how many problems matched up. And that's probably what you're going to see here on this exam too. And here I'm basically telling you what's going to be on there. All right, so there's the first 4 sections. The last 2, section 1.5, this is sort of a mishmash of equations we haven't solved just yet. So this was, what do we have here? We have, okay, so higher order polynomials, that's one type. Then more rational expressions. So let me write those 2 down. We had, I'll even say factoring higher order polynomials, right? And so that just means things that aren't quadratic. They're, x to the third is the largest, or x to the fourth, those types of things. And then rational expressions again. But this time, we had variables in the denominator, so it made them a little bit more difficult. But same thing, we just multiplied all the denominators together to get this factor, and then multiplied every term by that factor, and it got rid of the fractions. Okay, 3. So this is equations with square roots, right? Equations with square roots. Now with these ones, and I'll put in parentheses, must check solution. Right, so when you get your answers for equations with square roots, you absolutely have to check, because you could have some what we call extraneous solutions that really aren't solutions to the equation. And I think, was there anything else? Oh, right, there were equations with rational exponents. But I only gave you the most simple versions of those. All right? So we only have one more section. The one we just went over today. All right. Let's get up to the top here. We had just basically solving inequalities, right? They were simple. Solving inequalities. And we were given solutions in interval notation, right? Second thing we did was combine inequalities. And I'll put in parentheses, what I mean by that is the and the or. Right, where you end up having two of them. Okay, then we had what I'm going to call higher order. Again, this just means greater than linear. Higher order inequalities using the test point method, right? And that was the one I said today that takes a little bit of time. So if you see one of those on the exam, I mean, you're probably only going to see one of them, just because it takes a while to go through all those steps. Now, the last thing, and that was really it. The only other thing that we see here is rational inequalities. And I'll make your day and say you're not going to have to do rational inequalities on the exam, right? I'm more concerned with you being able to do something like this or something like this. So the first two examples I gave you, and I went over one today in the homework, they're the ones I want you to master. So don't worry about the rational inequalities, okay, that are of higher order. Hopefully that'll make less studying for you. And I believe that's it. So there you go. So let's see how many we have. I wasn't counting as we were going. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 what I would call problem types. I don't remember how many there were for exam 1. There was more or less. Well, how about that? They were exactly 15. I didn't even plan that, right? So there's 15 things to study for exam 2. Now again, go through this list, and if you're really good at some of them, like if you know how to do the domain stuff, spend less time on that. I'm not saying don't practice a problem or two, but spend less time on them. I would say focus on the ones that are giving you the most trouble. All right. And people who have taken my advice have told me that that was really helpful and they were getting good grades on exam 1. Okay, so that's sort of the outline. We have a little bit more time. Does anyone want me to go over any of these types of problems? I'd be more than happy to solve some more for you as well. Yes?
Is there a page in the book that kind of gives like problems for each section, almost like a chapter review?
There is. So I'll just give you an example. Do you have a specific section in mind?
Section like 1.6.
Okay. So like if you go within the actual chapter, so prior to the problem set, like I'll just go over, let's see. Okay. So the first thing in that section is just solving inequalities. After you go through, they give you a couple examples, which is nice. So you have my examples plus the ones they do. But then at the very end, before the next type of problem, it says practice problem 1. Solve each inequality and graph the solution set. And they're in yellow in the book. And then when you go to the end of that section, it gives you the solutions to those yellow problems. And by solutions, I mean like the answers. Like it doesn't go through the step-by-step solution, but you can at least check, right? So like I'm looking at section 1.6, and there are 10 problems there, right, that you could be potentially doing. And every section has those. So if you were looking for more problems to do, that's what I would do, okay? But in some sections, I don't cover all the material, so just make sure you're trying the problems of these specific types when you're going to do them. But yeah, that'd be a great resource just for more practice. Anything else that I could go over? Let me just check real quick. Did Lauren ever come in? No Lauren? No. Tika? I don't see Tika over there. Konstantinos? Nope. Robert Maroney? Didn't see him. Okie doke. Perfect. No questions. Okay, so we'll put to bed that exam review. We finished chapter 1. So with the remaining time left, I'd like to give you a little introduction to the next chapter. Okay? Just to keep on rolling. We don't want to waste any time. So, I hope you'll be happy to hear that I think chapter 2 is actually fairly simple. Because a lot of people have, graphed things before. So a lot of the beginning sections are just about graphing. And there's very little types of problems in each section. So there's not going to be a litany of things to do every section, just like, in the P sections. All right, so let's go ahead and do this. I'll just give you a little brief introduction. It'll be very simple. So we're all the way on. We're on chapter 2, section 2.1. And it's on the coordinate plane. Okay. Okay, so the coordinate plane has a couple names. It's XY plane, right? Because we usually give two, physical dimensions, the labels X and Y, just by, historical. Just by the history of it. But we really should be calling it the Cartesian plane. Okay? All right, so the Cartesian plane, it has 2 axes. Okay? So let's start drawing this thing out. Now, once we get to quizzes or an exam on this stuff, I'm not going to make you draw your own axes. I'll actually put a nice pair of axes right on the exam. That way it's easier for you to graph things. But for your notes, you'll just, do as best you can. Okay, so here's our set of axes. All right, the horizontal one we label X. The vertical one we label Y. Okay. what do we call this thing right here? At the intersection of the axes. Yeah. It's the origin. Now, what other geometrical property do the axes have? So when two lines intersect, there's angles between the two lines. Right? What are special about the angles between these two Cartesian axes? It actually defines what makes a Cartesian plane a Cartesian plane. Aren't they perpendicular? Right? Do they make 90 degrees? Right? So we have these angles are all 90 degrees all the way around. Okay? We could label, clearly there's 4 areas here, right? This we call quadrant 1. Over here is quadrant 2. This is quadrant 3. Quadrant 4. Okay. In order to label any position in this plane, we use a coordinate. And we put the x value first, the y value second. So we would say this piece here is the x chord, short for coordinate. And then this is the y coordinate. All review so far. So if I wanted to mark a location for, let's say, a coordinate, we'll call it coordinate A, and we'll say that coordinate is 3, -2. Right? This says that we're going to be going in the positive direction on the x-axis, right? So this is the positive x direction to the right, and then to the left here is the negative x direction, and then the same is for the y. This is positive y, and this is negative y. So anytime you're doing these, you want to try to make markings, right, to signify distances on your axes. So for this one, I'm only going to mark the distance tick marks for this specific one. So I'm going to go 1, 2, 3. Right? So that's to the right. And then I'm going to go down 2 because that's the direction of negative y. So if my y coordinate is negative, that's the direction I have to go. 1, 2. So then I can go ahead and label that point A. So graphing points are very simple. Right? We all right with this? Easy. Right? It's a nice little review getting us ready for the rest of this section. Well, I'm going to do you a solid. I'm going to let you go, just because I don't think I can finish the next piece of this part of this section, in time. So I'll just leave you go a little early today. But yeah, can I make one more announcement too? We are going to be in this room, right, for our exam. And I've noticed over the past couple of days there's people absent, and people have been emailing me about, COVID-related issues. But if you are going to be remote on Tuesday for the exam because of COVID, I am only going to release that exam remotely if I'm notified from your respective dean's offices. Does that make sense? Like, I'll just use an example. Michael, right? Are you KSOM?
Yeah.
All right. So, say something happened with you, right, and you had COVID. I won't be emailing. I'm not going to email you the exam until I get confirmation that that's actually true, because there's been some widespread stuff on campus where students are telling their professors, "Oh, well, I came in close contact," but they're lying about it. Now, I'm not saying anyone in this class has ever done that before, and I'm not accusing anyone of doing that, but just so I know people aren't taking advantage of the situation, and I know that there's a widespread problem, the only way I will email you an exam on Tuesday if you're not here is if I already have confirmation. So let's just say on Monday, something happens on Monday where you're in close contact and they want you to get tested and you're isolated. I have no problem giving you an exam remotely. I just need the confirmation. So what you have to do on Monday or any other day before that is get in touch with your advising center and have that advising center email me. And as soon as I get confirmation, and I really don't need to know details, I just need to know confirmation that you can't be in class, I will happily give you that remote exam. Yes?
What would happen if you get an email on time? Like, let's say like Monday afternoon, maybe it's like Tuesday afternoon.
So like you couldn't get in touch with somebody in time?
Yeah, like let's say they email you like before the class, like what would happen then?
So what would happen is, like, say something happens Monday late in the day, you can't get in touch, you can't get done what I just suggested. Email me, okay? And if you're going to email me and there's an actual issue, I'll still give you the exam. But if it turns out that you're lying, right, and then the dean's office doesn't tell me that there's a problem, I'm going to have to give you a 0 on the exam. Does that make sense? Like, so if it's an actual issue, you really don't have to worry about it at all, right? It's just there's been talk about campus about some people taking advantage of the situation, okay?
I just wanted to know what happened now.
Does that make sense, right? Because if there's an actual issue, I mean, I'm completely fine with that. I hope everyone understands who's worked with me, even in this class, that I'm very accommodating. It's just I want to make sure no one's taking advantage. Okay? So people who aren't here today, just, you're responsible for that announcement. So please be cognizant of that. Okay, folks, that's it. I'll let you go now. So have a great weekend studying. And again, on Monday, if you have any questions, email me. We can Zoom, talk about problems, whatever you want.